Welcome to the Plating Systems Lab. Mechanical plating. One of the keys to mechanical plating is, prior to beginning plating, to write out a run card. A run card details all the information about your plating process. What chemicals you're going to use, what your coating thickness is that you desire to plate to, what the part is that you're going to plate. In addition, it's important to pre-weigh, pre-measure all of your chemicals prior to putting them in the barrel. These are our laboratory barrels. We're going to use the barrel on the right, and you can see we have already loaded the media into the barrel. It's important to start off with clean parts. The parts that we've just put into the barrel were alkaline clean prior to going in the barrel. We've adjusted the water level. As you can see, the water level goes roughly through the middle of the barrel. So if you draw a line from side to side, it's about halfway between the left side and the right side of the barrel. We have now added our starter concentrate and acid to the barrel, and we're going to let this mix for about 5 minutes. If the foam builds like it has here, we add a little bit of defoamer. And you'll see that the foam quickly dissipates. You can see that the parts look pretty good, so it's time to add the copper. We've just added the copper, and you can see that the parts are starting to achieve a coppery color. Now, even though the copper shows almost instantaneously, it's imperative that you let the barrel spin for 4 to 8 minutes to be sure that you get as much of the copper out of solution and onto the parts as possible. Without a good copper coating, the promoter will not adhere to the surface or allow the zinc to adhere to the surface, producing the reducing metal that it's supposed to. This good copper finish is a mark that the parts were clean enough prior to going into the barrel. If you're unsure about the cleanliness of your parts, you can do the copper test outside of the barrel. If you have questions about this, please contact Plating Systems and Technology. Having achieved a good copper finish, we will now add the promoter. You should note that the parts that we're running here are straight 3/8 inch bolts, 1 3/4 inch in length. Now the promoter has been added to the barrel. We typically will let the barrel rotate for 1 minute. After this minute, we will add the flash, the small quantity of zinc. The zinc will act as a reducing metal to reduce the tin to the surface of the part onto the copper, and subsequently zinc will be added to the barrel, and it will build up the zinc coating over the tin that's been reduced by the zinc originally. The promoter has been there for a minute, and you can see there really wasn't a color change, but now we will add the zinc, which will reduce the tin to the surface of the part. If you listen carefully, you often will hear a change in the sound of the barrel. You can also see that the parts are starting to turn silver almost instantaneously. This will not always occur this quickly. In a cleaning process, it will happen very rapidly, but still not quite this fast. We will now let this go for a couple of minutes to be sure that we achieve a good silvery color before continuing to the zinc add process. It should be noted, the copper color that you get after adding the copper, again, is a direct representation of how clean the part is. You must start the process with as clean a part as you possibly can. A dirty part will cause problems in coppering, allowing the tin to be reduced down the surface of the part, and in making zinc dust adds. Often zinc adds that are made to a dirty part, you will be able to remove all the zinc from the surface of the part, often even down to the copper layer and below the copper layer, right down to the actual bare metal and the contaminants that's on the surface of the part. Okay, the parts have achieved a good silver color, so now we're going to check the pH before we start making zinc add. We see that the pH is somewhere between 1.3 and 1, so we can continue the process. Provided that the pH is below 2, we can continue plating. We'll now make additional zinc add. We're at least halfway through the zinc add process now, so we're going to check the pH again. See, the pH is still below 1, so we're okay. Prior to removing the parts from the barrel, it's a good idea to check the coating thickness. We use a CMI tester similar to the Oxford testers that are made today. It basically tests the distance between the probe tip and the underlaying steel structure of the part. This part tested out at 0.55, which is 0.55 tenths of a mil. We were looking for 5 tenths of a mil, and we achieved what we were looking for. You can hear the parts are still tumbling in the background. We've made all the zinc adds. Now we're letting it finish the 5-minute run-out period, and then we're going to water polish the parts. Okay, I've now rinsed the barrel a couple of times, and I'm on a very slow turn. I'm going to check the pH to be sure that we are out of the plating range. And you can see that we're well outside the plating range. So we can now water polish the parts. We've added the water, so we just turn the speed of the barrel back up to where we were before. And we usually let this go for a few minutes. You can let it go for anywhere from 3 to 5 minutes. The parts are ready to be removed from the barrel. So we will remove them, separate the media from the parts, dry them, and then show you what they look like at the end. And here's our final product. If you need more information about mechanical plating, please visit us at www.mechanicalplating.com. You can reach me at ndrpst@msn.com or david@mechanicalplating.com, and we can always be reached at 517-783-4776, fax 517-783-5875 in the United States. Thank you, and I hope you found this video educational.